Welcome to the Santa Cruz Coffee Break. If you're watching on YouTube or listening on Apple Podcast, please follow, hit the like button, or any subscribes. It really helps us with the algorithms. Santa Cruz Coffee Break is independent of Santa Cruz Guitar Company, and all opinions are those of the speakers. Santa Cruz Coffee Break is produced by the Santa Cruz Guitar Players Forum. We invite you to join us on the Santa Cruz Guitar Players Forum at SCGCPF for more fun. Now, let's get on with this installment of Santa Cruz Coffee Break.
Today, we have a special guest with us, James May, who is the inventor, creator, manufacturer, distributor, et cetera, of both the Tonic pickup and the Dexter pedal, box pedal, whatever. James will explain it all during this podcast. James is a musician, he's an engineer, he's an audiophile. He's done some really amazing things, specifically with the aim of reproducing an acoustic instrument's tone and sound when amplified as accurately as possible. And we are really, really glad to have him with us to talk about some of his work, his creations, and how it helps us as guitarists, especially acoustic guitarists, play our instruments more loudly to a larger audience, to record more cleanly, and get that same great sound that we've spent on our instruments. So I just want to say at the beginning, in full disclosure, that I have two of his guitars with Ultratonic pickups, one with the Ultratonic retrofit for a K&K, and I also have a Tone Dexter, and I am thrilled with all of them, which is one of the reasons I invited him to come and talk with us. So welcome, James.
Thanks, Ted. Nice to be here, Richard.
Okay.
I want to make sure that the forum people get that the fact that first we had James Nash, who talked about acoustic amplification from outside the guitar, and now we're going inside. So welcome, James. I'm excited for this one. This is great.
Yeah, thank you. Okay, well, I'll do my best to explain things.
Yeah, so as monosyllabic as possible. Most of the musicians listening to this. Why didn't you start off by just giving us all a little background? You know, your education, your training, your musical experience that got you going in this direction.
Sure. Okay. Well, there's probably a lot of components to that, but let's go back to the time that I was about 7 years old, and I saw the Beatles on the Ed Sullivan Show. And the following Friday, decided to go out and get myself a Beatle record. And within a couple of weeks, I was taking guitar lessons. So that was let's call that a pivotal moment. Started my, love of music and my all the things that I've done with it, which maybe I'll say some more about that. So so I'm, kind of a half self-taught musician, half formally trained, and I did a lot of things in my earlier days playing in bands, mostly electric guitar during those days, but a little bit of acoustic. And then, when I started my family and, decided to do the career thing rather than the be a musician thing, guitar kind of took a back seat, but I always had an acoustic guitar and was always playing that when I could. Since the kids have grown and so forth, I've been a lot more active with not only performing in various ways acoustically, but also writing. I'm a composer. I write songs. I'm a singer, and I've released a couple of CDs. So there's that. So I've had a fair amount of experience playing, let's call it, not really professionally, but semi-professionally, for money in a lot of cases, but not trying to make my living at it. On another track was the electronic engineering track, which I got into fairly early and spent a lot of time working for large corporations that were involved with telecommunications. And for people who don't know what that means, it really means sending data over the telephone lines. But way back in the old days, that used to be a dial-up modem. You probably all remember the sound of those dial-up modems. Well, I was, So I was one of the guys that was working behind the scenes to make that technology possible, mostly specializing in analog design and the front end designs, the front end design of those circuits that actually interface to the telephone line.
So you didn't get a commission or a royalty every time those little tones played while the modem was trying to hook up.
No, I got a headache.
Like the rest of us.
Yeah, I wish.
You and everyone else.
Yeah, those original ones were what they called FSK, or frequency shift keying. So it was a really simple system where a 1 would be one tone and a 0 would be another tone. And it would just wobulate back and forth between those two tones.
Wobulate.
Wobulate.
What
It's
a word.
technical term. Yeah, it's a technical term that only us certified engineers are allowed to use. But I won't tell anyone if you want to use it too. So so I got into that, and when the turn of the century came, it all turned to DSL, which is what a lot of people still have. And I worked in that field, working on DSL circuits from about 2000 to 2016. In fact, the gateway / DSL modem that we are communicating with here, at least on my end, I designed part of that circuit, and it was something that AT&T shipped a whole bunch of. I still have one. That's what. So I'm actually going through my circuitry here to get to you, which is kind of a neat little point.
That is. That's very
cool.
That's very cool.
Yeah, and just to not to belabor that, but it's interesting, and well, I'll get to it. But audio and telecommunications, at least the analog part of it, have a lot in common. They are both what you would call high dynamic range, low distortion, precision kinds of analog design. Specifically, they have to be high fidelity. You don't listen to the DSL signals, mostly because they're out of band anyway. You couldn't hear them. Maybe if you were a bat, you could hear some of them, but basically they're beyond our human hearing. And but many of the same principles apply to a good telecom circuit. Compare that to a good analog circuit, and a lot of the principles are the so. And I've also designed analog circuits as a hobby for a long time, until I started the audio sprockets company, and we decided to make Dexter, and then it became a professional endeavor. Audio and a lot of digital stuff too. We can talk more about that, of course. So
that leads into what I was kind of wondering is, so you're out playing music at nights, dragging your ass home early in the morning and trying to do your electrical engineering. When did an impulse, bad choice of words. When did you suddenly think I could marry these two together and make something creative? What was what clicked in you? What made that happen?
Right, that's a really good question, Ted, and the answer is actually pretty simple. Being an acoustic guitar player, I was like everybody else in the sense that when I went to plug my acoustic guitar in, and it's not just one, but I had several, they never sounded particularly good. The undersaddle pickups that came with most acoustic guitars, or off-the-shelf ones, they're predominantly undersaddle pickups. They have that characteristic quacky, brittle sound. And, I hated that. And when you plug in, it just ruins it. If you're sensitive at all to the sound and you care about a natural sound, it kind of ruins the experience. Not only does it sound bad, but it puts a damper on your enthusiasm to play, because what you're hearing back is really not your guitar, or so there was that, let's call that one component of the motivation to do it. And I experimented with different pickups, and I'll talk more about that perhaps coming up here. But so there was the being dissatisfied with the state of the art as an acoustic guitar performer, and also having a lot of electronic design experience in audio. So that was another component. And then, maybe the third part of it was in 2001, there was an Audio Engineering Society paper, and I used to be a member and get their, magazines every month. They're journals basically, and these are all peer-reviewed, vetted, papers that are advancing the state of the art. Let's just say, and there was an article in one of those around that time by the guys who ended up working for the B-Band company. You may remember that name. They made pickups, but they had this article about paper about how you could create an impulse response and apply that to the pickup on your guitar and make it sound like the microphone that was in front of your guitar. Okay, so this is a basic concept that has sparked a number of innovations over the years since 2001, one of them being Dexter. So that intrigued me. Now, the way that they did it wasn't particularly successful. They were actually using a little hammer and tapping on the bridge, trying to capture the impulse response directly as an impulse. And for people who don't know what an impulse response is, you can think of it as a complicated filter that's very good at describing how you want something to sound. Well, they were trying to create this impulse response by tapping, and that didn't work particularly well. But
they never figured out that people don't generally play their guitar with a hammer.
Well, yeah, that's a good point, and you might think that would matter, but in fact, an impulse response actually, in theory, can be gotten that way. So suppose you go into a nice reverberating room like a concert hall or something. Well, they capture impulse responses from those kinds of venues all the time. And one way to do it is to clap your hands, make a loud impulse, and then measure what comes back. Well, in an ideal world, that would work. There's a number of reasons that doesn't work. But if you try to apply that well, it does work, but there's better ways to do it. Let's just say it that way. But if you apply that technique to the guitar and you do a big tap right on the bridge, there's a number of problems with that, making that work well, even though theoretically it should. It doesn't. So there's much better ways to do it. And we found, through a lot of hard work and man hours, my development partner Andy and I found the best way to do that, we think. But the tapping was just sort of, that was the start of it. So, fast forward ahead, 2005 or 2006, something like that, the Fishman Aura came out, right? So that was a system that was impulse response based, where you could apply an impulse response to your guitar pickup with the hopes of making it sound like a mic'd guitar. Well, it kind of worked. The big problem with it is it wasn't your guitar that was being sampled or measured, let's just say. Measured is a better word. When they created those impulse responses, they were other people's guitars with Fishman pickups. And it on a good day, it kind of worked. For most people, it was a kind of a not really experience because, and Larry, if you're listening, with all respect, I respect you and all that. It just didn't work all that well, and it's because it was other people's guitars that were being measured rather than your own. So, and I learned that very quickly. I bought a Fishman Aura.
So it was basically the dial-up system of impulse response pre DSL.
Pre Tone Dexter.
Right. Yes. The first version, the baby steps.
Yeah. It was a step forward, let's just say, and having a box that could actually do that process of taking your signal and running it through an impulse response, that's called convolution. And it's not that hard to do. It doesn't take that much horsepower to do the playback part of convolution. So there was Sushminora, and then I don't know how many years later, that was 2006. So, you know, it was a few years where I got the bug to, you know, I thought, man, this can be done better. We could make a box. I could make a box. My friend Andy, I kept bugging him. I said, Andy, what? Help me out here, man. He's
Make
a
me a
DSP.
box, Andy. Make me a box.
No, well, it wasn't quite that, but he's a DSP expert, also from the telecom world. So he knows signal processing, you know, inside and out. Mostly applied to higher speed problems, but the same principles apply to audio, as I was saying earlier. So it's like, you know, why don't we make a box that allows the user to create the impulse response right there on the spot from their instrument, so that it custom fits like a glove. And finally he said, okay. So we started working on it. This must have been around 2014, actually, I'm thinking. So it's been, you know, probably 7 years since we started working on it. And it turns out, you know, the concept is easy in principle, but in practice, it's challenging. So we spent a lot of time, Andy and I, figuring out how best to extract the impulse response that represents the difference between what your pickup is sending to it and what the microphone is sending to it. For those that don't know, when you have a tone Dexter, the first time you use it, you have to train it. So you plug your pickup in, but you also plug a mic in and set that mic up in a favorable position. Sometimes there are many favorable positions. And then you tap the switch and you say, okay, train, and you play for about a minute, minute and a half. And you just kind of strum open chords, bar chords up and down the neck. It doesn't matter much, because what it's really doing is it's learning the resonant signature of your instrument. Okay, this is the complexity that makes an acoustic guitar sound beautiful. You know, if it was just strings by itself, you know, if you just amplified the strings, you'd have something very, very ugly. And that's basically what undersaddle pickups do, is they pretty much just hear the strings. So you're getting this quacky, brittle thing. Well, it's not the pickup's fault. It's the fact that it's located right next to the string, and there's very little of the guitar, the top plate of the guitar. It's very complex resonances. All that stuff is fairly much missing from an undersaddle pickup. So what a tone Dexter does is, whether you have an undersaddle pickup or a soundboard transducer, pretty much any kind of pickup except a magnetic pickup won't work, and I can tell you about that later. But whatever piezo-based pickup system you have on your guitar, tone Dexter will hear that. It will hear the microphone, and it will do what's called a deconvolution. And this is an adaptive process where, over time, it's listening to both signals, and it's doing a whole bunch of mathematics under the hood fast. It takes a lot of horsepower to do this, so that you end up with something in real time. And it's creating that impulse response, so that when you get to the end of the training process, you can audition it, you can listen to the mic, you can listen to your pickup by itself, you can listen to your pickup being processed by tone Dexter's impulse response, which, by the way, we call a wave map. It's just kind of a trademark name that we use. Fishman called their impulse responses images. We call ours wave maps, but basically they're impulse responses. We didn't want to use a technical word, because, you know, a lot of guitar players are not very technical. And if I'm being too technical right now, you tell me, and I'll try to change my tone.
No, I think you're doing really well so far. I mean, so basically, in my mind, what you're saying is that you're taking this signal that you're generating from a pickup that doesn't necessarily accurately reflect the sound of the guitar, and then comparing it to what a mic is hearing, and the mic can be any of a variety of mics and in any of a variety of positions. And then is it simply a question of EQing the two, of making adjustments at different frequencies, like a fancy equalizer, or is there more to it than that?
Yeah, that's a great question, and we get that one all the time. There's more to it. It is technically a very fancy EQ. However, besides just altering the shape or the curve, it alters the time response. So there's two factors. There's the magnitude and there's the phase. And the phase is basically another way of looking at a time delay. So what comes at the mic has delays. It's not instantaneous like it is at the pickup. So those delays, and they vary at certain frequencies, and there's echoes inside your guitar. There's, it's a complex thing, and it's not just zero time. There's complicated time relationships between those frequencies, and the impulse response captures that. So you can think of it as, in a sense, you can think of it as an 8,000 band graphic EQ, with each band not only adjusting the amplitude, but it can also separately adjust the timing or the phase.
And,
so that's what an impulse response is.
And it's learning as, is it a comparative learning, or is it AI?
It's not AI. It's actually a deterministic system that, it's a deconvolution. So what that means is, in the frequency domain, it's dividing one by another. So it's saying, what is this with respect to that? So technically, it's a frequency domain division. Now, how you accomplish that gets complicated, and I probably shouldn't, go into too many details about that. There's a lot of ways to do it, and a lot of ways don't work very well when you have. Let me just back up. So, this process of learning what a system is doing, let's call your guitar a system, and it's doing something to the string sound to make it sound like a beautiful acoustic guitar, which your mic can hear. Well, if you think of that system as a black box and you're trying to learn what it is, okay? Well, there's an analogy for that in all kinds of other fields in electronics, where you can put in a test signal and measure what comes out and easily determine what it's doing, okay? In the case of Tone Dexter or any other guitar-oriented box, you don't have a test signal because there's no place to plug in a test generator or anything like that. You've just got a person playing their instrument. So this becomes a more complicated problem because there's not a predetermined test signal. Those are easy things to do. This is a lot harder because of the unknown nature of what they're going to play. And no matter what they play, there's going to be some things that are good information to use when deciding what the impulse response should be. And there are going to be other parts that are not good to use. So you have to reject those parts. So it's a bit of a complicated, let's call it challenge, to figure out how to extract the good stuff and use that to create the impulse response, and not use the stuff that's going to make it sound worse.
So
I don't know.
It's this phase and kind of delay response that is how the microphone and the Tone Dexter is able to recreate the overtones and the other signal you get from the top of an acoustic guitar that is lost to pickup systems.
Yeah, that's right. That's well said. And it's lost more so to an undersaddle pickup than it is to a soundboard transducer. But even with the soundboard transducer, which has more of the guitar's personality in it, there's still a whole lot missing that only the mic or your ear can hear. So Tone Dexter, it kind of restores that. Now you might think, well, how can it do that if it wasn't there in the first place? We get that question a lot too. Well, it's the same way that you can EQ your stereo. If the bass is weak, you can turn up the bass control, or if the highs are weak, It's not that it's not there at all in the first place. It's just that the proportions are all wrong. So if you think of the impulse response as this really fancy equalizer that can adjust all these bands of amplitudes, and when you look at a guitar, it's got peaks and dips and peaks and dips, like hundreds and hundreds and hundreds of them. It's the complexity of that. It's what happens when you have a complex system made out of wood, and strings, and it resonates certain ways. It has certain modes. The top has certain modes of resonating. There's the chamber resonance, the Helmholtz resonance that's designed, the volume of your guitar, how wide the lip of the sound hole is, how big the hole is. All those things contribute to this really complex set of resonances that your ear wants to hear, because that's what we, over the centuries, guitar makers have figured out how to make these things sound great. Well, you can hear it with a mic, so Tone Dexter can actually adjust your pickup so that it sounds like that.
And that also leads to, if you're used to playing with a mic because you don't like the sound of different type of pickup systems, then you have the option of training the Tone Dexter with the mic that you like.
Mm-hmm.
So it actually carries one step further. Then you have a certain amount of adjustment once you've got that wave map made, of making some adjustments within the Tone Dexter itself.
That's right. Would you like me to talk a little bit about that?
Sure. I mean, let's see.
Yeah.
We've learned convolution, deconvolution, and wobulate. So yeah, go.
Yeah. Okay. I guess I have to be careful.
No. We're all learning here.
Yeah.
Like, I just have to figure out how to use wobulate more frequently in my life.
Yeah, that the wobulate would not pass a peer review, but nonetheless, I'm going to use it anyway.
It would
So-
go with my peers.
We can't vet that word. Yeah. Okay, good.
Yeah. So you mentioned, Tad, a really good point about performing in front of a microphone. So I want to say a little bit about that, because this is something that I've found actually a lot of musicians don't really quite understand why that doesn't work very well. You would think, okay, put yourself in front of a mic, and if the mic is not feeding back with the PA system, if the mic is just sitting there by itself, and you turn the PA up, and you're using a cardioid mic, which means it's directional, so it's not picking up the speakers very much, it's pointing a different way, and it's not feeding back. How come when you put your guitar in front of it and start playing, all of a sudden it starts feeding back? What's going on there? Well, what's going on there is those resonances of your guitar, particularly the lowest few, are big. They're peaking up 6, 8, 10, 12 dB above everything else. And what that means in simple terms is that they're 2 to 4 times as loud as everything else. And when you put that in front of a mic and you amplify it loud, comes back and it hits the top of your guitar, and it amplifies it some more, and it creates a feedback loop because it's so much louder than everything else. This is why you have problems playing in front of a mic at elevated levels. It's because the resonances of your guitar are working against you. So Tone Dexter, it creates its wave map, but we now have an intelligent feedback control. It's the notch knob on the left that says, okay, if it's fully counterclockwise, it's off. It doesn't do any of this helping thing, and it just sounds like the mic. But if you turn that up to a certain level, you probably will start having some feedback problems, just like you would if you went up in front of the mic. It's going to be the same. So if you do have that problem, you turn up this knob until the problem goes away. Now, what does this knob do? Well, because we know what the frequency response of your instrument is, because we've just learned it and created this impulse response, we know where those troubling hot spots are, those low frequency resonance points that are going to start feeding back. And we've got those pre-programmed into this control. So when you turn it up, it starts knocking those down proportionately. You know, if this one's sticking up here and this one's sticking up there, it starts taking them down so that you won't feed back eventually. You turn it up all the way and it'll just knock them down so they're flat.
So it's not like a notch filter you might find on a lot of other things, which is a set frequency that you are engaging or disengaging. With the tone Dexter, it's actually intelligent enough, well, maybe not intelligent, but it analyzes the frequencies and can determine what those problem frequencies are and adjust those specific frequencies instead of a fixed range or a fixed set.
Exactly. Yeah, that's well said. And not only does it know where the frequencies are, but it knows their relative, how loud they are relative to each other, and it knows how wide they are. They're not all created equal. Some are narrow and some are a little wider. Well, we know the profile, so we just program that into this control, and it just counteracts whatever profile is there. You can think of it as sort of a negative profile, and it just starts getting rid of itself until you turn it fully up, and then it flattens the whole bottom end. So what does that sound like, you might ask? Well, what it sounds like is if you play in a nice acoustic guitar, you're going to get a fair amount of low end bloom. Let's use the word bloom. It's like the bottom end has a richness and a resonance, and in fact you can hear it on most guitars. If you play a low G or a G sharp, you can tell that's louder than the other notes down there if you're really listening for it. So that's the Helmholtz resonance. That's the chamber resonance. And then you go up on the D string to an E or an F or an F sharp. That's going to be the first mode of the top plate. I'm talking about a typical dreadnought or an orchestra model kind of a guitar. Those are typical things. Even a nylon string. Well, those resonances add to the richness of the sound, but they also trouble you when you're trying to amplify it. So if you use this, let's call it intelligent feedback mitigation control, and you get rid of all of that stuff and you just flatten out the whole bottom end, well, what it sounds like is it sounds like a guitar. It still sounds rich and complex because you've got all the high frequency resonances are still there. And that's what gives it the lush quality, the sounds like wood. Okay, if you take away the low stuff, it just thins out the bass a little bit. You don't lose bass, you lose the bumps in the bass response. So it will sound a little thinner, but when you're amplifying it in a room, you're not going to notice all that much. What you're going to notice is you don't have feedback.
Right.
So it's kind of a win-win situation.
So that's an adjustment you might use depending on the amount of amplification, the size of the room, other variables like that, which.
Mm-hmm. Right. And if you don't have feedback, if you're in a small venue with well-controlled acoustics, then you might want to dial it up just a little bit just to make the bottom end not as bloomish, not as much bloom on the bottom. It might sound better to cut a little bit of that away, even if you don't have feedback. So it's an artistic choice also.
Right. If you're playing somewhere where the PA system is used primarily for Disco Thursday.
Yeah.
Humidity affected?
A good question. That's a great question. I think you're the first one to ask that, Richard. You win the prize. It's a common word, something you hear around the house. Remember that say the secret word thing?
Yeah. The
Well,
duck fault.
Come on, James. The duck didn't come down.
We're gonna drop a duck here in just a second.
Yeah. Wait a minute. Let's see. What have I got?
Yeah.
Well, no, it's a scoping camera. Never mind.
Drop a potato.
Yeah, there we go. Right. So humidity and temperature changes. What happens? Well, they don't move these things around all that much. So it actually still works real well.
Like my question is just, I know that we live a pretty normal humidity here. I'm in Monterey, so we're we're pretty solid, you know, on that thing. But you go into South Florida, you know,
Right.
and your guitar sounds different, you know.
Yes. Yeah, it does.
Your guitar does sound different, and
Right.
I just that's, but it's really interesting that it's how it sees its signature. You know, it's beautiful.
It's there for the seeing if you know how to look.
It's beautiful. Yeah,
Yeah.
it's a beautiful thing.
Yeah.
Wow.
Yeah. So the one question I've seen people be confused about is that the Tone Dexter doesn't allow you to make your $99, you know, Father's Day special Guitar Center guitar sound like a pre-war D28. That was, I think, one of the early goals of impulse response work, was to be able to take whatever crappy signal you got off of whatever crappy guitar, but make the sound coming out of the speaker sound like, you know, some amazing $200,000 Martin or something.
Right.
And that's not what this is about. And that's not your goal here, right?
That's right. Yeah. I mean, you can attempt to do that, and in some narrowly defined cases, you can make a little traction toward that. For example, if you have a solid body like a Yamaha silent guitar, which is just kind of a block of wood with strings on it, it's not totally solid. It's hollow a little bit, but it doesn't have any real sound. You know, you might call it an electric guitar almost, but it has a piezo bridge pickup. Well, you can use that with wave maps that you've made on other good sounding guitars, and you can get, you know, half or 2/3 of the way there to something convincing. It kind of works. The problem is if you try to do that on another guitar that has its own resonance profile, even with an undersaddle, there's enough of it that comes through that they clash. And then you start to get this hazy, muddy, phasey thing going on. And, you know, this is really the Fishman Aura problem. You know, you can't really do that guaranteed most of the time.
Right, right. Okay.
Yeah.
And one of the things I remember when I first heard about the Tone Dexter, one of the things that convinced me that it was a really incredible thing was the use of the Tone Dexter with other instruments, in particular violins, violas, and double basses. It was able to allow these instruments to be amplified in ways that, I mean, I should say simply amplified in ways that, you know, was mind-blowing.
Yeah.
And I mean, that to me is what's really so magical about this thing. You can do any stringed instrument that has a pickup, piezo pickup.
Yeah, that's right. Yeah, and what that really says is that, in a way, the problem is the same. You know, you have an acoustic resonant instrument with strings. It doesn't really matter what that instrument is. The process is the same. And what we have made sure that we do in our algorithm, where under the hood we're doing this adaptive deconvolution, is we don't really do anything that's specific for a guitar. It's generic, and it more or less works for every instrument of any range. We do have a separate version for bass, and I won't go into all the reasons for that, but you can use bass on the regular version and it still works fine for the most part. So the process is pretty, let's say, agnostic. It doesn't really care what you're playing.
Yeah, yeah.
Beautiful.
Yeah.
Beautiful.
No, it's these use on these other instruments. And that leads me to a question I never really thought about is, what kind of traction are you getting with string orchestras and other instrument? I mean, besides guitarists.
Yeah, well, you know, probably none with symphony orchestras, but we have a lot of violin players and upright bass players who are playing, you know, a variety of styles, not usually in a classical orchestra, but they're playing, you know, in a bluegrass band, or they're playing, you know, jazz on the violin, or we have a lot of jazz bassists, but you know, just generic upright bassists. We're selling quite a few to both those camps. And don't forget mandolin. Mandolin's another big one. And we've, you know, we've sold probably more tone Dexters into Nashville than any other place.
I'm a mandolin player, and I'm just, my mind's just exploding as to how this thing works. I mean, especially for mandolin. I mean, it's complex.
Yeah, and you know, you don't really have to get your mind around how we're doing what we're doing.
Yeah,
I
no.
think you just need to understand what we're doing and what you can apply that to, and then you'll be, you know, you'll be happy. Your ears will smile because it will sound pretty much like it sounds. You know, it's very, very close.
Wow.
In a blind test, you might not know.
And you don't need a ridiculously expensive mic to get really great results. I think that you recommend, I bought a little a reference mic, I guess it was around 80, 90 bucks.
Yeah.
That does a really great job of training the tone Dexter.
Yeah, that's right. That's another question that we get a lot is, do you need a fancy mic? And the answer is no, you just need the right mic. And what's important for training tone Dexter is a nice flat, even response, okay? Because you don't want the mic to have a personality, because that personality may conflict with your guitar. Because remember, it's going to hear your instrument as heard by the mic. So if the mic is giving you a boost at 10 kilohertz, and a lot of them do, or 8 kilohertz, and sometimes that boost is 6, 7 dB, it's a lot, can be a lot. Well, on a voice that may be nice, but on an instrument that's going to give you some harshness up there that you don't really want. It's much better to use a flat, just a small diaphragm condenser mic if you're using sort of a studio kind of a mic. And you can get some really good ones for $150. Or you can go the other way and buy a measurement mic. Those are omni, which means they pick up equally well from all directions. And you can get those for less than $100, you know, 59, 69 bucks. They will sound great if you experiment and find a good spot.
So will those actually pick up the ambience of the room that you were recording in? I mean, if you happen to have a room where your guitar just sounds awesome, would using an omnidirectional mic and training your tone Dexter in that kind of a situation be able to recreate that kind of sound in an environment?
You'll get some of it. It'll only last for about 100 milliseconds. So it's not real long. You're not going to hear it as reverb. You might hear it as just a bit of a liveliness to the sound. And you'll get more of that with an Omni than with a cardioid. And that's actually one of the reasons that we originally only recommended the cardioid, because a lot of times you don't have a great sounding room. And when you mix a bit of that in, if there's enough of that into the sound to color the way it sounds, it won't work as well when you're trying to amplify through a PA system. Ideally, you want it to not have too much room in it or none. So if you're using an Omni mic, better to go into a more dead space. If you're using a cardioid, it really doesn't matter much. You can do it in your living room or your bedroom, whatever.
And finally, what about using a tone Dexter for recording? I've not tried this, but I think I've read that you can actually plug the tone Dexter straight into a recording device, a DAW or whatever you're using, and be able to get that good tone into a recording, even if the kids are in the room screaming and the dog's running around barking and the doorbell's ringing and whatever else.
It's true, yeah. And most people don't think of that because live is the bigger problem. But you're correct. Sometimes you want to record and you don't want to go to the trouble of getting out the mic and setting it up. You're just in the mood to hit play and go, or hit record and go. And like you said, sometimes there's ambient noise issues that you'd rather not pick up on your recording. So yeah, it works great. And it works so well that you might say that if you're doing any kind of ensemble track where you've got other instruments and a guitar, using a tone Dexter is probably going to be as good as using a mic, because it's that close. Now, if it's a solo guitar recording, well, then no, you're going to want to use mics, and they usually use a couple to get stereo and a big sound. But if it's just a regular track in a pop song or a folk song, it will work really well.
Cool. Yeah.
Wow.
And then, I mean, I don't know if you can do any name dropping, but I've noticed you've had a number of rather big name guitarists talking about how much they love the tone Dexter. So you're clearly making some inroads with some big names.
Yeah, I mean, I can't talk about all of them, but some of them I can. I mean, Molly Tuttle is the most recent, sort of public face.
Mm-hmm.
John Jorgensen was one of the early adopters. Peter Frampton, Emmylou Harris uses one. There's a bunch, a lot of bluegrass folk. There's a band called Balsam Range out of North Carolina. They use 5 of them, one on every instrument. It's a traditional bluegrass ensemble. And I saw them live with their tone Dexters here in town a couple of years ago. Man, they sounded great. And they're a fabulous band. So that's a treat. When something like that shows up in your backyard, it's like, oh, yeah. And they were super happy, super nice guys. So,
fantastic.
Yeah, we've got quite a few. So, yeah, I mean, it's always nice when somebody who's well-known, recognized, gets on board. The bigger names, which I probably shouldn't say any of them, but sometimes they buy them and they may use them or they may not use them. It's complicated. The bigger the machine you've got working for you in the background, sometimes the harder it is for changes to get implemented. And those guys, or gals, whatever, they don't want their name associated with anything. So, you can't say anything. But yes, we have some very well-known people and a lot of people who are just pros who may not be well-known, who are using it and are extremely happy. And that's very gratifying. I love music and I love all kinds of music. So anyone who buys one and gets a great sound, I'm thrilled.
Yeah.
If they're thrilled, I'm thrilled.
That's awesome. So
And, I should point out that was the original motivation too. It wasn't to start a company to try to make money. That wasn't the reason we did it. We were trying to make enough money to keep it going, obviously, but it was to improve. We were tired of going to hear our favorite guitar players, who are incredible musicians, sound like crap because of the pickup. It's just Andy and I were both like, we got to fix this. And not just for ourselves, but for these other ones that we want to hear sound good,
it's very similar.
Paul Simon, if you're listening, give me a call.
I was going to say your sentiment there sounds very similar to what I've heard our friend Mr. Hoover say about building guitars, as well as the reward is not necessarily in the financial gain, but in the tools that you give the universe to make it a better place. So I for that. Yeah, that was the motivation, and in many ways it still is the main motivation, because it's something that Andy and I could do, and it benefits others. Well, and it's a shame about the lack of residuals on the modem tone, but you'll have to remember that.
Yeah.
So
in the next deal.
Yeah. So you've got the tones Dexter all developed, and that's doing really well. What motivated you to decide that you needed to build a better pickup?
Right. So you would think that because tone Dexter could basically fix any pickup and make it sound 95% or more like the mic, why bother, right? Well, it turns out that everyone doesn't want to buy a tone Dexter. There's a lot of people who either they can't afford it or they don't want to carry another box around with them. They just want to go to an open mic and plug in. there's reasons to have as good a pickup as you can have if you don't have a tone Dexter. And actually, there's reasons to use, the best pickup you can start with and a tone Dexter. And I should talk a little bit about that. It's a question that I get asked sometimes on the forums, is if I have a crappy a crappy undersaddle pickup that's quacky and brittle, and I use a tone Dexter to make it sound really nice, how different is that than if I start with a soundboard transducer that sounds better to start with and then go through a tone Dexter? What will the end result, how will it be different? And what I always say is the sound is going to be similar, but the feel will be different. When you're playing through an undersaddle pickup, when you hit the string, that pickup directly transduces that sound immediately because it's coming right off the string. So it's a very quick attack. Let's call it the attack characteristics are very sharp. And that's not how your guitar sounds. So tone Dexter will take that and it'll make it sound like your guitar, but it will still be a little bit different than the acoustic version of it because of that quick attack. Now, the untrained ear may not notice that. Certainly if you're playing in a bar, no one's going to notice. But the feel as a player, you'll notice it if you're sensitive. If you use a soundboard transducer, what happens is that string has to get the wood moving first before the transducer picks up the signal. And that difference in the attack, that attack is a lot more natural sounding. That's more what your guitar sounds like. Even though that soundboard transducer won't have all of the overtones that your mic can hear or that your ear can hear, it will have a fair bit more than the undersaddle. So that's going for it. And it has the right attack characteristics. So the reason to have a good soundboard transducer is those two things: to give you the best sound you can get from just the pickup, and to give you the right attack characteristics, and to give you a hassle-free experience so that you don't happen to have your tone Dexter with you. You can just plug in and you'll get a usable sound that you're not going to be ashamed of. Mm-hmm. So that was the motivation for developing the Ultra Tonic, and I'll talk more about that after I clear my throat.
Oh, no problem.
So everyone, I think, knows the K&K. This is probably the most popular soundboard transducer. And for those of you who don't know what that is, it's the K&K is 3 little piezo discs that get glued to the bottom of your guitar on what's called the bridge plate, which is a piece of reinforcing wood that's a thin piece of wood that's right underneath where your bridge and saddle sit on top of the guitar. And that's all it is. It's 3 ceramic piezo transducers wired together to an output jack. And what does that give you? Well, it gives you a lot of what I just said, but it gives you a problem. And the problem is that it gives you too much of the guitar's resonances, meaning the Helmholtz resonance, the chamber, plus the first and second mode of the top plate. Those are usually the biggest ones. You're going to get too much of that in most cases. Now, it's ironic, but the better your guitar, the more of a problem you're going to have with this. And that's because the better the guitar, in general, the more flexible the top plate is, the more responsive it is.
Right.
Makers, they're careful to brace the guitar as much as they need to, but not more than they need to. Because if you brace it too much, it becomes stiff and it doesn't sound very good. It doesn't sound resonant. Well, if you get it just in the sweet spot, that plate's pretty flexible, and you will get off of a K&K too much boom and mud in the bottom, and you'll have a feedback problem in most real-world situations. So that kind of was the state of the art a few years ago. There are some other soundboard transducers that give you, you know, a slightly different sound, but they all work in essentially the same way, and they all have too much feedback problems.
I was going to say that's the other problem with the piezos or the soundboard transducers. If you have a very responsive top to guitar, that guitar responds to any kind of noise or sound or vibration that's in the environment.
Yeah, and the one that will kill you is the sound of your guitar being fed back at you through the speakers.
Right.
That's what sets up the feedback problem.
Yeah.
And even if it doesn't feedback, if it's sub feedback levels, it still muddies up the bottom. So like if you play you know, let's say you play a B on the A string. Well, it's not all that far away from that G sharp on your E string. And these resonances are not really very narrow. The Q is not high. They're kind of medium Q resonances. So that B will affect and excite that G sharp a little bit. So that B is going to sound kind of like muddied up. And you won't know why exactly, but that's the reason, is because it's exciting a couple of resonances that are sort of mixing in with the sound you want to hear.
But this is part of the lushness and reverb and tonal quality that you look for in a lot of higher end, higher quality guitars. I mean, it's not that it's entirely a problem. It's unamplified. You're kind of looking for a lot of that stuff in a really well-built guitar.
That's correct. But when you put a transducer on the bridge plate, you exacerbate the problem a lot.
Right.
That's why it doesn't sound like your guitar sounds like when you listen to it. Just by the nature of the physics involved.
Right. Well, and I think that also may be why when people say, well, so-and-so plays, you know, this cheap guitar on stage with, you know, whatever pickup, it's because in those situations, they're not looking for overtones or any kind of lushness of tone. They're just looking for the audience to see them holding a guitar and making some very loud guitar-like noises with it.
Yeah, that's true. I guess that's true in a lot of cases.
I'm having this amazing experience of thinking, playing professionally in the early 70s with a D35 Martin, that I had this Barkus Berry. It's like, what was it? An inch and a half long and a half inch wide. It was
right.
just, and you like would try to figure out where to stick it, you know, that you would have the best.
Yeah. And
then stand in front of a twin reverb with JBLs, you know. I mean, it was complete suicide. And you know, you play a lot more electric guitar, you don't play a lot of acoustic guitar.
Right. Well, so that Barkus Berry, you know, that's a piezo disc also, you know, and it's just contact to the top of your guitar. And you know, you're going to have more problems with that actually, because you can't get it right underneath the saddle, which is the optimum place to put it as far as the most string to problem, you know, signal to noise, string to problem, resonance. You can't even get it there. You're getting it a little bit removed.
Mm-hmm.
So you're getting a higher mix of resonances that you don't want and the string sound, you know. So yeah, and you shouldn't be standing in front of a twin reverb with an acoustic guitar. No matter what. I know.
I'm asking for a friend.
Yeah, right. Because the acoustic guitar police will come and write you a citation if you do that.
I was hoping more that they would come and just take the Martin because it was such a terrible guitar.
Yeah, no, they've been trained these days to take the twin reverb.
Good.
Yeah.
If they can carry it, they can take it. Go ahead, take it. I think that the amount of problem solving, I hope people understand the importance of this soundboard issue, you know, of the right mic in there. When I look at your product, it looks like you're using 2 to 3 piezo's, correct? And then they go into a little circuit board. Or
Yeah,
is that just a separator? Is there a physical circuit in there, or is that just a separator that lets you then lets your system talk to each pickup?
right. I was leading up to that. I'm glad you
Sorry,
asked.
sorry.
That's okay. So what the ultrasonic then is, I just kind of laid the groundwork for why there's a problem with soundboard transducers up until a few years ago. So I put my brain on this problem and I thought, well, there may be a way to fix this. What if you could take another sensor, not the ones that you've already got in the typical location, but what if you could put another sensor a little ways away, and that other sensor then would pick up not nearly as much of the direct sound that you get when you strum the strings, but it's going to get essentially the same set of top plate resonances and chamber resonance. So it's picking up the same, let's call it this, roughly the same amount of the bad stuff, to use a simplification, and not nearly as much of the good stuff. And if you could mix that in out of phase with the other one, you could cancel the bad stuff and not really cancel hardly any of the good stuff. Okay, and you can. This is kind of analogous to a noise canceling headphone, or you could even think of it as an electric guitar. It's a little bit analogous to a humbucking pickup.
Yeah.
So a humbucking pickup has got two coils that are hearing the good stuff, but they're out of phase to the bad stuff, meaning the stuff that's coming in as far as hum and buzz magnetic fields. So that's the basic idea behind an ultratonic. It uses a separate sensor to pick up the stuff that you don't want, and it's out of phase with the main sensor or sensors. They act as a group. And you then, when you set it up, you get to mix in exactly how much of that cancellation thing you want to mix with the other. So to answer your question, my circuit board, you can think of it as a stepped attenuator that is roughly 2 dB steps. It decides how much of the feedback cancellation sensor you're mixing in with the main one. Okay, so it's like a volume control.
Yeah.
And it's adjusted during the setup phase where you've installed the sensors, and now you let the wire hang out of the sound hole. You plug it into an amp, and you try. There's 12 positions. You just try them all until you find the one that gives you enough of the cancellation, but doesn't suck out too much of the bass. That's just to put it in simple terms, and that's pretty easy to find. Tad can probably speak to this a little bit because I think you've done this, right?
Oh yeah, and well that's what sold me on the ultratonic pickup is having a baritone guitar, which is a wonderful thing to play acoustically, but when you try to amplify them, especially a good baritone, they are so resonant because they have that deep bass, tone. They feedback like crazy, really, really easily. And so I put an ultratonic into that and got the switches set. And I can sit that guitar, right in front of an amplifier, no feedback, and it sounds great. I mean, it was mind-boggling to me that you could actually accomplish that. And it was really, I got to say, it was really pretty damn simple. And the reason I can say that is I did it by myself, so it couldn't be hard.
Right. Yeah, it's not much harder than putting in a K&K. Placing the sensors, you have to be careful. And doing that setup phase where you have to select the switch position, that really only takes a few minutes if you're used to it, or if you're not used to it, maybe 15 or 20 minutes at the most. So it's, to me, it's time well spent because of what you achieve at the end. You achieve something that's otherwise non-achievable. I mean, I don't know of any other system that can do this. I do have a patent on this idea. So I patented this very concept. And the patent office didn't seem to think there was anyone else doing it either. And
Congratulations.
so I'm glad about that.
Yeah, congratulations. That's enormous.
But the thing is it's really, on the latest version of the Ultratonic, it's really not that much more difficult. In fact, I'd say it's almost easier to install than the K&K, because you've taken the 3 primary piezo discs and put them into a single capsule, a single elongated disc.
That's right.
Which is actually easier to install because it's just a one-piece glue-on thing.
Yeah, in fact, I have a show and tell here if you want to see it.
Right. And for anybody who's listening to this as a podcast, there are images that we are going to have available that we will try very hard to explain.
Or James's website.
Or James's website, yeah.
Yeah, and I'm sure that you'll put a link or something.
Yeah.
Many.
So, yeah, I don't know if you can see this, but
Yeah.
there's actually, this is the steel string version. So those 3 sensors that a K&K would have now been replaced by this one. It's a piezo disc. It's the same kind of thing, only it's made in an elongated form. So you only have to place one of these.
That's brilliant.
And furthermore, another detail is, you put it right underneath the saddle as closely as you can get, and usually the saddle's at an angle, so you angle it to match, and you center it left to right. And what you don't see is that there's a built-in bias inside this thing, so that it gives you a little bit more on the high side than the low side, because almost always your high string, especially the E, comes out weak if you just put in a 3-disc K&K. Well, with this, it won't. So that I've solved that little problem too. And then the other sensor is this one. So I should back up. The first sensor is, for those who care, 10 by 72 millimeters, okay, with rounded edges. The feedback cancellation sensor is 21 millimeter, it's a disc. And this goes on the far base corner of the bridge plate on a steel string guitar. So it's, a good 1.5 inches, 2 inches away from the main sensor, something like that. And its location actually is not very critical. You want to get it away from the main sensor a bit, and you want to either have it in the center or on the bass side. But if you don't have enough room on your bridge plate, you can just take it off the bridge plate and go off onto the actual bottom of the top. It works just as well there. In fact, on nylon string guitars where there is no bridge plate, the system works perfectly well. So those are the 2 sensors. Here's the little circuit board. I don't know if you can see this. Yeah. Okay. So, and what's important here is there's a little disconnect here.
Oh, stop it.
Yeah. So this, when you mount these, you don't have to have, this isn't involved. You're just mounting this. And then this comes out the sound hole, and you plug it in with just one little action like that. And it's high friction. It won't fall out. Makes all the contacts. Then you plug in, and then you can experiment with the switches, and you set it up. Now, why did I do this? Well, there's a number of reasons, but one of them is if you're a guitar manufacturer, i.e., let's say Eastman, you can mount this pickup system to the top of your guitar before you've put that top on the body of your guitar. And you can just tape off the pigtail and deal with the rest of it later. And I said Eastman because they're actually using this in one of their models now. There's one other feature that this has, and that is, and I got a lot of requests, for my original version of this didn't have it, is a sound hole volume control that mounts right underneath the top part of your sound hole, and the little wheel sticks out. Now, the whole system is passive, and for any of you engineers out there who might think about this, putting a passive volume control on a passive pickup driving out to typical loads is problematic. It was non-trivial to design this system so that this volume control doesn't affect the tone when you take the volume down. You know how on an electric guitar Les Paul, even a Strat. When you have the volume up on full, you're getting the full signal, but as soon as you turn it down a little bit, you're muting the highs.
We call it a treble bleed.
Well, you can fix it with the treble. Yeah, you can fix it with the treble bleed capacitor on an electric guitar. The problem is different and more difficult, I would say, with this kind of a system.
Oh.
So I won't go into the gory details, but suffice to say, I've designed the whole system so that with this volume control, you have no compromise. You can plug this into any impedance. A typical instrument impedance is 1 meg. You can plug this into anything from 500K, which is half that, on up to 10 megs. It doesn't matter. You'll get the same sound.
Wow.
So it's not picky about that.
James, that's absolutely brilliant. It is truly absolutely brilliant, and the fact that it's passive.
That's huge.
It's I can't put a pickup in. I can't put a battery in an acoustic guitar and give it to an airplane.
Yeah, I mean, I hate batteries for a lot of reasons.
Yeah.
And, environmentally, they're not good, but they're also a big pain in the butt when you're playing your gig. You don't know if the battery's lost its charge or not,
Right.
And if it has, it's a royal pain to change it in a hurry, that kind of thing. So I don't like batteries.
It's
Oh,
really
the thing that's
brilliant.
the thing that's even better is that he's made a K&K retrofit, which I was really intimidated by. But basically, if you already have a K&K installed, you can cut the 3 leads off of there, separate out the wires, solder them to that circuit board of his, install the extra disc and the volume wheel, and train it or adjust it, I guess, not really training. And you've got an ultrasonic. You aren't out the investment or hassle of removing the K&K or anything else. I mean, it's great and it works fantastic.
Yeah, thanks, Ted. It works just as well. So I always recommend, if you have a K&K and you want an ultrasonic, don't bother tearing it out and sanding your bridge plate back down. That's kind of a chore. Just put in the conversion kit. It will be equal at the end of the day.
Wow.
And you've made some models for other instruments, right? I mean, I haven't really looked that carefully because I only play steel string guitar, but
yeah. So the other one that's real popular is this, what I call the nylon string version. So instead of the one elongated sensor, you have just 2 18mm discs. Okay, kind of like the K&K has 3. Well, this is 2. They're bigger. And on a nylon string guitar, mostly they don't have bridge plates. And I should back up and say, if you don't have a bridge plate, you have a more flexible surface underneath where the strings are bearing down. And what that means in practice is you don't have to be as picky about where you put these sensors, and you don't have to cover the area as thoroughly and precisely as you do on a steel string guitar. So whereas on a steel string, 2 sensors, placed under the B and the a lot of times that wouldn't cut it. But on a nylon string, it always does. It always works because there's enough flexibility in the top that the sound over a very short distance of, a couple of millimeters, it doesn't fall off very fast. So you're basically getting everything you need to get with these 2 sensors. And then it still has the same feedback cancellation sensor, same circuit board. It's all the same volume control. So it's only the main sensor that changes its form.
well, and I have to say that the new style pickup was actually so easy to install. And we may need to edit this out, but I mean, basically what I did, James, is I put bridge pins in the 2E string holes, put some crazy glue on the sensor, held it up and slid it up against the bridge pins, and then backed it off 1/8 of an inch, and then held it there, but taking the bridge pins out to make sure I didn't accidentally glue those into the guitar. And really the hardest part was getting my fingers unstuck from the pickup. There's a little DNA that'll be going along with that guitar for centuries.
Right. Yeah, latex gloves are good for that. you'll leave a little glove behind, but not your finger.
Yeah.
Yeah.
But I mean, it was really simple because you could just bump that whole sensor right up against the bridge pins and then just slide it back, a little tiny bit to make sure that the ball ends on the strings didn't ever accidentally, run into anything there. It was really easy.
Yeah, and my instructions, there's a way to do it with magnets. You can use a magnet to both position and clamp the sensors. It works pretty well.
It does. Yeah.
Yeah.
I discovered my magnets weren't strong enough.
Well, the strong ones are easily come by. So there's more than one way to skin this cat, but the point being, it's not that difficult once you get a little bit used to it.
And the same is true with the K&K retrofit. Was tinning and soldering the wires from the K&K piezos onto your little circuit board was really amazingly easy. I was intimidated by it for a bit, but when I actually did it, really wasn't a problem.
Yeah, good.
Yeah.
So so that's the Ultratonic, and it's been around for, I guess, started about 3 years ago, something like that. It's spreading by word of mouth mostly. I don't have much of an advertising budget, so it's kind of like the Tone Dexter. It's kind of a word of mouth spread, but it is slowly increasing, which is good.
Yeah. No, that was one of the reasons I wanted to have you on our podcast, is because I've been so impressed with your products and your, just the approach you take to producing the highest quality things that you can for acoustic musicians in particular. I thought I love them. And so that's why I was hoping to give you a chance to talk to the couple dozen of our forum members who hopefully will catch this, and who knows who else in the outside world, now that we're on Apple Podcasts.
Yeah.
Right. It's such a solution oriented product. I mean, it's so solution based. It's like, and it's really, my wife's going to be the happiest person in the world because she'll never have to stick her hand inside and glue a K&K again. I mean, because I can't put my hands in there. Go ahead. Yeah.
Right. Most of you is cut off. Your camera is moved.
Yeah.
Your head's not, there we go.
There we go.
Yeah. Now it looks more like you. So yeah.
I wonder what happened there. Strange things are happening in my house in the past couple of weeks. We've had some interesting things. So we'll just go with that then.
I just wanted to make one comment on your last point. Yeah. I appreciate you saying that, and it is true. My motivation is to give musicians a tool that will actually help them in a big way, and not only that, these are the Tone Dexter certainly, and the Ultratonic. They're made without compromise as far as the quality of the components, the circuit designs. The Tone Dexter is unlike any other pedal, almost any other pedal you're going to find. It's got pro level power supplies, high signal to noise ratio, high headroom, very low noise. It's robust. It's designed to last for a long time.
Is it 18 or 9?
Well, okay, without trying to be too technical, and you'll appreciate this, I think. Most pedals take 9 volts.
Yeah.
With a negative tip,
yeah.
Negative pin. Well, Tone Dexter takes anything from 9 to 15 volts with negative or positive center. And internally, it converts it to a whole bunch of voltages, plus and minus 15 for all the analog circuitry. There's 5 volts, there's 3.3, there's 1.2, there's 48 volts. It's doing a whole bunch of stuff on the inside, sure. But it basically doesn't care much what you give it, so long as you have enough power.
That's fantastic. That is even more application oriented.
Yeah, because I'm an engineer, of course, but I'm also a user. So when I do this stuff, I really want me, the user, to be satisfied with what me, the engineer, has come up with. So that's that was a real strong component of, all the stuff that I'm doing.
Beautiful.
So, what's next on the horizon, James? Where have you set your sights next?
I don't know if I have. I've been pretty busy with keeping these things going, and we're small. I wear many hats. Most of the hats I wear them. So that takes up quite a bit of time. And I guess what's next is trying to get more guitar manufacturers interested in incorporating the Ultratonic. I've been working on that. As I mentioned earlier, Eastman has it on one of their models now. I guess I should say, I mean, most of the users who listen to this probably won't care, but the setup thing that we talked about, where you have to spend a few minutes and set the switch position on the Ultratonic, well, for factories, that's not a practical way to do it. So I developed an automated test system that runs on a computer and has a little speaker in front of it. You just set the guitar down in front of the speaker and you click a button on the computer and it sweeps the guitar with the sine wave, measures what comes off the sensors, and it says, okay, position 3, please. It only takes about 10 seconds. So I've got an automated system that works in factories, but I have a couple of luthiers that are using it too because it just saves time. It doesn't do anything.
No iPhone app?
No. Yeah, I'm not that crazy because keeping up with the changes in operating systems on smartphones is more than a full-time job, which I don't want.
Yeah,
yes.
Yeah, I can only imagine. James, thank you so much.
Yeah.
Oh, you're welcome.
I mean, really, my mind is really kind of truly blown. I'm checking my bank account going, well, I have this 52 Gibson that is a problem child that really needs a pickup.
What kind of a Gibson?
It's a CF 100. It was a 14-inch dreadnought they made. They made them for just a few years. It's got a Venetian cutaway on it.
Yeah.
And a thick body. So everything that's possibly wrong there is wrong. Plus, it was part of a marital dispute, I believe, in where it was used as a weapon. And it's been rebuilt from the holes in the side and the broken off headstock and the neck and the top that was shattered. But no, the top is original, and I'm dying to put a pickup in it, and I think I know what I'm doing here.
Yeah, I mean, I have my main gigging guitar for the kind of stuff I do these days is a Gibson Advanced Jumbo.
Yeah.
It's a recreation of the old one from the 30s. I think it was built in 2006 or something like that. And it's a great guitar in a lot of ways, but it does have a really overpowering bass response that, with the K&K, I just couldn't get it under control very well. Yeah, but with the Ultratonic, it's beautiful now.
Yeah, beautiful. Ted, I'm done. Thanks. James.
No.
I mean,
I think we need to just make sure to mention that there is lots of great information on James' website. Lots of videos and training and recommendations, and you should check him out on YouTube and all those other places. We'll have all those links on the forum. But I think the one thing that we didn't really touch on is anybody who's been on the guitar forums, who's ever had a question about the Tone Dexter or the Ultratonic, James responds like within a day. If you run into a weird situation, something you don't understand, and you email him, or even just post it on a public forum, James generally is there and has the solution like, boom, which is so rare these days. And so I think that's something that needs to be acknowledged, is how well he supports the people who use his product.
Thanks, Ted. I try to. And I try to, go public with all the answers to the questions that, first of all, people have, but that are, kind of murky because of, let's say, marketing departments not exactly making things clear about what's really going on with the physics of their instrument or the electronics. Well, I don't play those games. I'm an engineer and like to stick to the facts. But I like to help people, who maybe are just, undereducated about how this stuff works. And, a lot of people just don't have access to this inside information. So I like to share it because I think it helps. I hope it helps.
This is a master class.
Yeah.
Truly a master class. Really wonderful. Thank you so much.
Yeah.
Enjoy the day.
Thanks, Richard.
Thank
You're
you,
welcome.
guys.
Yeah, nice to be on.
Yeah.
Ted, nice to see you.
Nice to see you too, James. We'll look forward to maybe doing some more in the future with you. And, next time we'll talk more about your music, which I know
Sure.
is something that we should cover. But I have a feeling we've already run over our time limit here.
Yeah, we've been pretty thorough. So, yeah. Well, good. I'm happy to have been here.
Thanks,
All right,
everybody.
Thank you.
Peace out.
Peace
Okay.
out.
Bye.
We hope you enjoyed this installment of the Santa Cruz Coffee Break. For more music-related fun, please join the Santa Cruz Guitar Players Forum at scgcpf or santacruzguitarplayers.com. If you have any questions or possible podcast topics, please contact us. If you have a product or service that you feel would be of value to our listeners, please consider adding your support and keeping the coffee pot on. Contact us for more information. We ask that you hit the like, follow, bell, or bookmark buttons so we can keep you informed of upcoming podcast episodes. We hope you enjoyed Santa Cruz Coffee Break. Now it's time to go play your guitar.